Hello and a warm welcome here from Hamburg. I'm here today with my colleague Maurice, and we have today our first seminar to the BAU Online 21. Unfortunately, not in a face-to-face meeting on a nice booth in Munich. So for us, it's a complete new situation because, it's simply something different. For the organization, you will have the possibility to ask some questions in the chat, and we will answer these questions at the end of the session. So you have, again, warm welcome. You have already seen, Maurice, maybe we say something up front, what we are doing in our position. I have seen it. I'm in charge of the export department, and Maurice.
Yes, my name is Maurice Leise. I'm working in WEBAC since 2011, so it's my 10th year. I'm working together with Markus in the export sales department, and I'm responsible for technical advices, consulting on site, and sales in general. So I just would like to hand over to Markus again.
Thank you, thank you. So you have already seen the company presentation, but I would like to spend some words about who we are. We are located here in Hamburg, and WEBAC is a producer of construction chemicals. We was founded 1978. We are still a medium-sized family-run company with a daughter company in Poland and in Norway. Production is only, and there I come to the next slide, production is only here in Hamburg. This is important to know. Everything is here centralized. We have short ways into the laboratory. We have our research and development center here, because you can imagine we do quite a lot of export business. So, and with these things, with different climate zones, products have to react different in different climate zones. Okay, we have used here now our seminar room. We made a studio out of it, a TV studio. Normally, we have here trainings, face-to-face, trainings for applicators, training for site managers, but also training for designers, different kinds of, as an example, designers are more focused of the durability, site managers or applicators. There we're doing here also hands-on training. We also provide the service that we give you project-related advice and propose solutions to make the right decision of the material. So, Maurice, I think this should be enough because time is limited and we have only a slot of 1 hour. Today, our live seminar, it is regarding post-construction damp-proof course. Sounds complicated, but I hope it will not be. So, Maurice, it's your turn.
So the schedule for today or for the next 30 to 35 minutes in general is about the sealing of masonry, like Marco just have mentioned. So the rough overview of today's schedule is we are talking about the damage diagnosis, the active principles, and for sure about the injection procedure. Or in the end, we're going to show you how an injection into masonry is carried out. First of all, we need to talk about some general things. We will now start with different kinds of masonry probably you are aware of that. So there are different kinds of masonries like ashlar masonry, uneven exposed masonry, prairie stone masonry, and cyclopean masonry. The reason why we are talking about the different kinds of masonry is simply that the injection procedure and injection material has to be adapted on the type of masonry you are having on site, and also the injection target. If it's just a sealing target, or if you just want to seal your construction, or if you also have to do some reinforcement work with your masonry, has to be adapted to the situation on site. So, roughly, how is a masonry injection carried out? First of all, you are going to mark and drill your drill holes into the construction. As you can see here, we are talking about an even masonry, so it's rather easy to adapt the drilling distance and also the angle of drilling. As you can see, you are not really going to inject into the stones, it's more or less injecting into the joints of your masonry. And as you can see here, this masonry is based on a concrete foundation, so often the weak point in such constructions is the construction joint between the wall and the concrete slab. And as you can see on this picture, you are able to also seal this construction joint during the injection. So in general, we are talking about our main topic today is the post-construction dam-proof course. Short form is DPC. What does that mean? It means that we are going to stop the capillary horizontal water transport in porous buildings, and this is usually going through the joints in your construction. The second thing that you can do is to make a restoration of an existing building, by meaning you are going to install a post-construction barrier into the structure by injection. Prior to your injection, or the idea of what you're going to do, you need to make sure that you have a rough overview about your construction. So first of all, you have to know what kind of masonry do you have. Is it sand lime bricks? Is it quarry stone? Are these solid bricks? What kind of structure do you have? Is it only a single shell, or is it a multi-shell construction with air between the walls, or is it a closed formation? Do you have a homogeneous wall? How is the strength of the construction, the density and the porosity? And for sure, you also have to be aware of your construction thickness, because the drilling has to be adapted to that. What kind of foundation do I have, and where is the position of it? Has some waterproofing been installed prior to your injection? Is there some kind of bituminous coating, bituminous sheets inside the structure? Where are they located, and what kind of? Do you have supply lines that are going through your construction? Because you have to be aware that you do not hit these supply lines, because then you're in big troubles. And does somebody has done some injection or some reparation works prior to your injection that you want to going to take to do? So maybe this is a picture that you are aware of. You have a masonry with some salts on the surface, so you know that there is some trouble with moisture inside the building. But you have to be aware what kind of moisture do you have. Is it rising moisture? Is it vertically penetrating moisture? Do you have hydrophilic pressure? Do you have condensate formations from inside because you're not venting enough? Do you have surface water? To make this more clear, or the distribution inside of the moisture inside the building is very important to know, because then you have to adapt your injection procedure and injection material on the kind of moisture stress you have in your building. To make this a little bit more clear, we have now here an overview about the different kinds, how the moisture is going into your structure. We're going to start on the left, and on the left you always see the outside, and on the right hand side the inside of your structure. We're going to start with the capillary rising moisture, by meaning the moisture is going to penetrate from the bottom slab up in your wall. Maybe this is related to groundwater. The next thing is a vertically penetrating moisture. Just imagine you have periods with a lot of rain that are going to the exposure side of your building. So the rain is going to hit the outside of your wall and is penetrating through your construction to the inside. The other thing, and this is something that is common in older structures, is the hygroscopic moisture, by meaning you have salts that are sticking to the inside of your wall. These salts are hydrophilic, so they are going to suck the water to this construction, and you see that the moisture is going from the inside in a higher degree and is getting less to the outside. Last but not least, maybe you have condensate because of changes in heat and cold temperatures. We just want to make sure with this line, as you maybe can see, that the damage from the inside is looking more or less the same with every type of moisture-related stress. So the damage inside your structure may look the same even if you have different kinds of stress that are that causes a trouble to your construction. So therefore you need to make sure what kind of stress do you have prior to carry out the injection. So now we're coming to the active principles, and in general we are going to achieve 3 targets. The first of all is gap filling. What do we mean by gap filling? By gap filling, we mean that we are going to fill cracks inside the joint structure, or even the stones, tiers and gaps have to be filled. Filling of cavities, you never know how the cementitious joints are, in which kind of conditions, or even if you have hollow areas in your stones. So therefore it's also important to fill up these cavities inside your structure. And the most important, and this is what you can see on the right hand side here, is the penetration into capillaries and finest ramifications. This is only be achieved by a pressure injection, and as you can see, the mortar joints and the masonry bricks, they have very, very tiny and small cracks that you cannot see visually. And our injection materials are able to penetrate into these fine fissures, fine cracks, seal them, and make a long-lasting sealing inside the brickwork. That was a general overview about the sealing of masonry. I now would like to hand over to Markus again, and he's going to talk about different kind of materials.
Okay, thank you so much, Maurice. In regards to material, this is a very good question. So most of the horizontal barriers or sealing of the brickwork we are doing with polyurethanes. And these polyurethanes are mostly a 2-component product, and they have a low viscosity. You see my colleague is just mixing it. He pre-mixed the components, add some water to show you the behavior of the material. It is a ductile material. The viscosity, we have different kinds in our product range. So it starts from 30, 40 megapascal seconds. So to have a comparison, water has 1 and honey, let's say in general, roughly 10,000. So again, they have a ductile behavior, so it's possible that they take also movements after the injecting, yes. They are water reactive and they are a long-lasting and permanent sealing. They have a watertight cell formation, so, and they are also you can also use them in combination with more or less all materials. Another class of material are the acrylic gels. They are more and more in the focus of the industry because there you have the big advantage that this material has even a lower viscosity than polyurethanes. So we are talking about 5 megapascal seconds. They have also these excellent adhesion to dry, damp, and also wet substrates, and they are adjustable in the reaction time. So after the reaction of the product, you see it here, the glass is cracked open, you see these flexible behavior. So, and due to the low viscosity, acrylic gels are penetrating really good into the substrate. Okay, but let's take a look at the workmanship on the site. There we have prepared a small video for you. So, like Maurice mentioned earlier, first you mark your drilling holes. You are drilling, and it's important, Maurice will come to the point that you hit at least 2 mortar joints. So, and after the drilling work, you are removing the drill dust. That's very important to not clog the pathway for the injecting material. Afterwards, you are installing the packers. There you find a lot of different types on the market, from hammer-in packers to screw packers. So, and there you see the drill channels are hitting, in this case, 2 or 3 joints. There you see the injection process. Then you go from left to right, from right to left, however, and you see it very good at the joint at the bottom that there's a material is coming out. So, and there you see the material is coming out at the next borehole, and this is for you the best visual control that the material was penetrating along the mortar joint and kill it. After a while, within the pot life, you do a secondary injection because the material gets sucked into the construction. So this is simply to ensure that you have filled everything. Afterwards, you screw out the packer, close the bore holes, and then you have done a good injection. Okay, Maurice, I would like that you tell something a little bit more about the drilling.
Thank you very much, Markus, for your explanations. As you may know, there are different kind of principles or solutions on the market for the sealing of masonry. We are usually talking about, in our case, about the pressure injection, and now we just want to summarize or give you the advantages of the pressure injection compared to other solutions. Due to the pressure, you have an even distribution, even if there is a high water saturation inside your structure. What does that mean? In general, this simply means that you are able to push out the water out of your structure and replace the water with the injection material. It also achieves a high degree of pore filling up to capillary obstruction, by meaning your small cracks and fissures in the mortar joints are completely filled with the injection material, and due to its properties as a long-lasting sealing, you have a watertight structure, or there is not any further influence of water moisture on your construction. You have an even distribution inside the masonry. You are increasing your penetration due to the pressure, and for sure this is also increasing your efficiency. From our experience and some German regulations, there is a rule of thumb more or less how to drill. The distance between the packers, depending if you are working in a 1-layer or 2-layer system, in this case it's a 2-layer system, the distance between the packers should be 10 to 12 centimeters. If you are working 1-layer, or here it's going to be approx 25 centimeters, and the distance from one to the second row has to be approx 8 centimeters. Why is it like that? The target is to hit as many mortar joints as possible with one drilling, and it should be at least 2. The material is penetrating mostly through the joints, and as more joints you have hidden, the better is the penetration of the injection material inside your structure. Most of our clients are asking, how deep do I drill into my structure? And there is simply, once again, a rule of thumb, or there is a German regulation, and that is saying that you need to have at least 5 centimeters distance to your wall. In our opinion, we say that it's better to drill about 3/4 of your wall thickness into the structure. So you can see it here. The drilling is not going through the structure. There has to be some space inside the structure. And the reason for that is simply that the material is looking for the easiest way to get out of the structure. If you would drill too close to the end of your structure, the material would easily penetrate throughout your structure, and you do not have the distribution inside your masonry. So therefore, you need to have a certain distance where the material has a back pressure, some blocking, and is able to penetrate through the construction. Once again, drilling distance 10 to 12.5 centimeters. Try to hit at least 2 joints, and the distance depends on the type of masonry. If you have an even masonry, then it's usually 8 centimeters distance from one to the second row. For sure, it can be that you have to adapt your drilling angle. Normally, we are saying that the drilling angle should be approximately 45 degrees, and that's rather easy if you have an even masonry, because then you're pretty sure that you are going to hit at least 2 joints with this angle. If you have uneven masonry with smaller and bigger bricks, then for sure it might be necessary to adapt your drilling angle. It can be slider, it can be above 45 degrees, but still the target is to hit as many joints as possible, and you can see it here. With one drilling you hit 1 and 2 main joints and 2 further joints where the material is able to penetrate. So therefore it's always necessary to see what kind of masonry do I have and how do I have to drill? That was now the general part, and now we would like to come to some examples where you can see it more visual, what we were just talking about. So, as you can see here on the left-hand side, there is a building where you can see that there is a little bit of moisture. It doesn't look too bad, but you can see that there is an influence on the masonry. What you can't really see is where the main problem is coming from. And in that case, it was simply that you have the problem underneath your screed. So therefore, it's very important to remove anything that is in front of your building, even if it's tiles or screed. It's always very important to see or take a look at your masonry itself, not on the parts that are in front or above of it. And you can see it here that there was really hygroscopic moisture in a bigger scale underneath your screed. So therefore, the main problem was not above the tiles here, it has been underneath. So it's once again very important to take a closer look at your building itself. So, and now the second example is, once again, you have you take a look at your masonry, and it looks not that wet. It looks rather dry, and you cannot see, do I really face a problem here or not? And on the right-hand side, you can see that the guy is injecting here from that point, and the continuous water, even in a, it's like spreading out of the next packer. So you can see that by the pressure injection, you really replace the water inside your structure with the injection material. Just imagine you are now in the case that you are using a non-pressurized system to try to solve this solution. You just pour in something by gravity, but then you will not be able to push away the water inside the structure. Last but not least, there is one other sample site report that Markus is going to present to you now.
Thank you so much. I think this picture shows best why a pressurized injection is necessary, right? Yeah. Okay, come to a case. I hope you can understand. You can see it there. This is a bridge in Bavaria, where you have moisture from the road on top, and over the years it's also a mixed building with stones and in some areas not compacted concrete. And over the years, I don't know if you can see it, here you find a crack which goes through the joints, through the stones, and there's a target for the renovation was also to glue everything together. So there I come back to the materials. In our days you also find polyurethanes which have the capability to, let's say, have a force transmitting behavior, and they nearly have the properties of epoxy resins. So, and this was carried out, and here you see in the arc the wet spots. So, and especially in a mixed construction, there the right choice of material was a hard polyurethane. Okay, we are close to the end, and you don't see it, but I see there. There are a lot of questions. We will not be able to answer them all, but Stefan, can you tell me what is? There was some question, but I can't read it.
Well, Markus, thanks guys for this great presentation. Very professional to bring these problems a little bit closer to us to explain some things. Let's say I have some questions here, and I pick some interesting questions out of them. First, I think Maurice can answer that a little bit in a little bit details. What if there are two shell masonries or cavities inside bigger wall structures? Is there an option to do the waterproofing also there? What is your advice in this case?
Thank you for the question. Yes, there is also the possibility for a suitable solution for two shell masonries. Usually you have a rather big hollow area there, and there are two ways of sealing them. One is a traditional way by using cementitious mortar or cement in general, and the other solution might be to use a high expanding PU foam to seal and fill up this area. The differences are simply that, as you may know, the cement takes a long time until it's fully cured, so it takes up to 28 days, and that's our recommendation, to not do the injection prior to these 28 days. If you are in a little time hurry and you need to finish the construction earlier, then the suitable solution would be first to inject this hollow area with a high expanding PU foam, and afterwards, like we just have seen in the presentation, using the PU resin to make a long-lasting sealing.
Okay, okay. So by meaning you need a bearing behind, and it's also important to know where the water is coming from. What is the pathway?
Yes,
for the water?
for
Okay,
sure.
got it.
Thanks, Maurice. And also, Markus, maybe you can answer that. Interesting question. What about different temperatures on site? Cold temperatures, warm temperatures? Do they have some influences of these dam-proof courses?
Yes, for sure. You cannot answer this in general, but for sure we are talking here about construction chemicals, which has a exothermal process behavior. So temperature depends on the situation. As I mentioned before, it is different if you are in the north of Norway or in the desert. So, but this we have to see it case by case. Okay, there are popping up some
More questions?
Some
Maybe
more questions?
you're able to ask us some more.
Yeah, there's another. I pick another
What-
one.
What's the most used?
Most used injection material for this purpose, acrylic or 2K PU? That's the question also.
Yes.
Oh,
From the experience, as you know, we are a German-based company, so our main market was Germany or Central Europe, and still it's like especially in Germany, that the PUs are mostly used for the masonry and the injection. For sure, both material types have their advantages and disadvantages, but if you ask us for our opinion, still the PUs are more common for masonry injection than the acrylic gels, but both options are possible.
sorry to interrupt you, but I think the question is also in regards to the injection technique. So also polyurethane injection material is a two-component product, but you apply it due to the long pot life with a 1C pump.
Yes.
And for the acrylic gel, because of the very fast reaction, you need a two-component pump. I guess that was also the question.
Yes.
Yeah.
Okay,
yeah.
there's another question, maybe could be also interesting. Are there any epoxy resins for such damp areas? What can you say about this?
Let's say it like this. In general, water, I say water and epoxy don't like each other. But in our days, you find also moisture-tolerant epoxies. So that works, but there again, we have to make a analyze in regards how much moist is in the brickwork.
Yeah.
Yeah. So, and there maybe again the hint, you find also PUs. You find also PUs which have the same mechanical properties like epoxy. So
Okay.
there I would recommend maybe a hard polyurethane.
Another interesting question, maybe Maurice can help in that case. Is there only a horizontal injection possible on one level? I'm trying to explain this question. Or is it possible to inject the whole masonry with this polyurethane resins, for example?
Yes, you can also inject the entire masonry, but usually the weak points are at the bottom of your construction of your walls. So usually the moisture is penetrating throughout the slab into the structure. And you want to achieve the horizontal barrier as deep as possible. Just if you make the barrier in this, maybe I just skip to another slide, just a second. Maybe that would work. If you imagine that this is your construction, that this is your bottom slab underneath here, and you have your masonry on top, if you're going to achieve a ceiling barrier close to the bottom slab, then there is no way for the water to penetrate into your structure. So in most cases it's enough to inject close to the bottom slab, because then the water penetration is not possible and your wall is going to dry after some time. In some cases, maybe if you have pressing water from the outside, then there is a chance to inject the entire masonry, or even doing a curtain injection, and this would be one of our presentations in a later stage.
Yeah, but we have here, you have seen here on the picture. So in this case, we have filled, because there was a lot of hollow areas, and in this case we have filled these hollow areas. So yes, it is possible to inject the whole construction. Additional questions?
Maybe one last question at the moment. What do you say about how can we prevent that the resin can or will flow out of the wall, for example, or how can we let's say what can we do if we have some bigger amounts which will fill cavities inside? Is there a possible option to use different types of materials?
Yes.
Yeah, that's you mentioned it in the beginning.
Yeah.
Proper preparation of the injection process, that is a key point. Yeah. So maybe you take out some drill cores to see what is inside. But again, maybe you can add some.
Yes. It's also the task of drilling. For sure, there always will be some resin that comes out of your structure. So first of all, to prevent that the material is coming from outside or to the outside,
I can go back, and here you see,
yes,
you don't want to waste the material on the outside.
Yes. So therefore, you need to drill up to 3/4 approximately into your construction. So then you mostly prevent that the material is coming out from the outside. And for the inside, there is also an advantage if there is resin coming into your structure, because then you can see visually how the resin is penetrating through the joints. So if there is no material outcome from the next packer, which is also a good thing that you can achieve or to control the flow of injection, you maybe see it through the connection of the joints that the material is coming out from another joint. So that is also a visual control of your injection. And in case that there is some big voids in your joints and there is a lot of material coming into your structure, just be prepared for some patching of the joints for example, using a fast setting cement to just block the joints and keep the material inside the structure.
Right, you never know. Okay, super. Thanks a lot. So, if you have further questions, so make a screenshot now from our mobile numbers and our mail
Email
addresses. Raise your question. We cannot answer all the questions right now here.
No,
I see there are a lot of more.
there are some more, but for sure we are able to answer further questions in the one-to-one talks during the BAU online. So there are time slots like for the next hour where you can book a one-to-one meeting with Markus or myself, and we can go into more detailed discussions then.
There are some sketches, some photos would be of help.
Yes.
Okay, that was a good point. Here you see now our next online seminars at 11 German time. We will have the same presentation in German at 3 o'clock. We talk about curtain injection with acrylic gels. Tomorrow you have the possibility to book the meeting for crack repair in concrete. English speaking at 11 in German, and at 3 o'clock tomorrow the curtain injection German, and I'm excited for Friday.
Yes.
Yeah, because there we are taking you to bigger building sites.
Then we are talking about our consolidation line, and this product line is about the tunneling, mining business, and special engineering projects. So this is completely another word compared to the ceiling of masonry, but also very interesting.
But you are not here, I've heard.
No, unfortunately not, but Stefan is going to take my part on Friday.
You only have heard Stefan's lovely voice. So if you would like to see him in front of the camera, join our seminar on Friday. Again, I would like to thank you, and I see here on the list of the participants, we was all around the world. Yeah. Thank you.
Thank you for your attention. See you soon.